This mini lecture is on balancing chemical equations. All chemical equations take the format reactants, then a reaction arrow, and products on the right side of the reaction arrow. This is where one or more reactants rearrange their atoms to form one or more products. All chemical reactions take this format. As an example, let's take a look at the combustion of propane gas. C3H8 is propane, which reacts with oxygen, and you get combustion reaction, you burn. Then you get carbon dioxide and water as products of this reaction. So we would read this equation as propane reacts with oxygen to form carbon dioxide and water. One of the basic laws we must follow is that matter is never created nor destroyed. What that means is, if you count your atoms, you'll notice you've got 3 atoms of carbon on the left side as a reactant, and you've only got 1 atom of carbon on the right side as a product. Somehow we've lost 2 atoms of carbon, and this just can't happen. If you take a look at hydrogen, you'll notice that there's a disparity between the hydrogen on the left side of the reaction arrow and also on the right side, and there's also a difference in the oxygens. We have to fix this. And so what we do to fix this situation is that we balance the equation. And by balancing, we make sure that the number of atoms of each element on both sides of the equation are the same. The biggest rule to remember is that you may only place a number in front of each element or compound. You may not adjust the subscripts. So this is how we do it. We kind of put an imaginary line between the reactant and the product side of the equation. And the first step in this process is to take an inventory of all your atoms. On the left side of the reaction as a reactant, you have carbon, hydrogen, and oxygen. So you must also have carbon, hydrogen, and oxygen as products. The second step in this process is to count all of your atoms. You take an initial inventory. So on the left side of the equation, we have 3 atoms of carbon, 8 atoms of hydrogen, and 2 atoms of oxygen. And on the right side, on the product side of the equation, we have 1 atom of carbon, 2 atoms of hydrogen, and you have to be careful because there's 2 atoms of oxygen with the carbon dioxide and also an atom of oxygen with the water. So you've got actually 2 plus 1, a total of 3 atoms of oxygen on the right side of the equation. The third step, save oxygen for last. This is one of the little helpful hints in balancing chemical equations, is that we save oxygen for last because sometimes oxygen can be in more than one place. So save oxygen for last. We put in the coefficients to gradually balance the number of atoms. The coefficient is the formal name for the number that goes in front of each atom or molecule of reactant or product. That's what those dashes are in front of each of those. So the first thing that we're going to do is we're going to balance for carbon atoms. And so in order to do this, we put the number 3 in front of the carbon dioxide. This gives us 3 atoms of carbon on the left side of the equation and 3 atoms of carbon on the right side of the equation. But by putting that coefficient there, you have also changed the number of oxygen atoms, and so we have to account for that as well. So now we have 3 times 2 is 6 oxygen atoms on the right side of the equation, but you also have to count that oxygen along with the water. So you've got a total of 7 atoms of oxygen on the right side of the equation now. So the next thing that we're going to do is balance for the hydrogen. We're going to put a 4 in front of the water because we've got 8 atoms of hydrogen on the left side of the equation, and we need to get 8 atoms of hydrogen on the right side of the equation. But again, by putting a coefficient of 4 in front of that water, you've also changed the number of oxygens, and so you have to go back and add up the oxygens again. 3 times 2 is 6, plus 4 is a total of 10 oxygens. So then we look back to the other side of the equation, and by placing a 5 in front of the O2 as a reactant, you can see that we now balance out the oxygens. We've got 10 on each side, and this equation is fully balanced. Some combustion reactions can be really, really tricky, and the tricky ones are the ones that have an even number of carbons. If this was C4H10, this would be a little bit more challenging to balance. The last thing that we do is we put a 1 in front of the propane, in front of the C3H8. And what this tells us is it gives us some eye candy that lets us know that this equation is completely balanced, that we have a coefficient in every open position, and that means that we're done. There's a really good reason to start with combustion reactions. While they are the most tricky, if you can balance these, then you have a pretty good chance of balancing almost all the other chemical equations you're going to encounter. Some helpful hints. If you're balancing a combustion reaction and you end up with a coefficient that is not a whole number, like 4.5 or something like that, in order to get whole numbers in front of all of your reactants and products, you multiply everything by 2. Multiplying everything by 2 will take that 4.5 and turn it into a 9, and you'll have whole numbers in front of all of your reactants and your products. Second helpful hint, 3 and 2, what do you got to do? This also works for balancing equations. There may be some cases where you have a 3 on one side as a reactant and a 2 on the other side as a product, or vice versa. And you're going to have to use the least common multiple thing to solve that problem. Another helpful hint, when balancing, we know that we have to save oxygen for very last, save hydrogen for second to last. If you get real stuck, start over from scratch. And the good news is you'll get to the point where you should be able to do most of these in your head. There'll be some that are challenging, but most of these you'll be able to do in your head. Now these are hints. They don't work all the time, but they're strategies to use if you are getting stuck. Good luck.